Let's look at the difference between linear and angular speed. Let's suppose we have a donut and we mark a place on the donut. The donut then rolls along our table, and the part that we marked is now down here. So if I look at this top point as it rotated around versus this bottom point as it rotated around, we can see that the top point had further to go to get to our new location than the bottom point. The one on the larger circle had a further distance it had to travel. This is because the outside point had a larger linear speed. So linear speed is distance divided by time. Things like miles per hour or kilometers per hour, meters per second, something like that. When we're talking about a circle, our distance that we travel is going to be the length of an arc. So we'll denote our linear speed by v, and this is going to be equal to the length of the arc divided by the time it took to do that. So our linear speed is given by s over t. We know that s is r theta, so we could also write this as r theta over t, where r is the radius and theta would be my intercepting angle. At the same time, my outside point and inside point on the original and new circle, they went around the same number of rotations. So in other words, their angular speed is the same. So angular speed works a little bit differently. First, it's denoted by the Greek letter omega. And the angular speed is looking at how many times you go around the circle. So that's going to be given by theta. Theta tells us how far around the circle we've gone, divided by t, which is our time. We can also see that if I multiply this by r, I get v. So we also know that linear speed is equal to the radius times the angular speed. Let's suppose the blades on a windmill are 6 feet long and they make 3 full rotations per minute. So I want to know what is the linear speed. Linear speed was given in 2 different ways. We can think of linear speed as r theta over t, so we would need the radius, the angle, and the time. Or we could think of it as r times omega, where omega is my angular speed. And in this problem, we have our angular speed. We can see that we make 3 full rotations per minute, and that's what angular speed is looking at, is how many rotations you make in your given time. So omega is 3 rotations per minute. We also know my radius is 6 feet, so my linear speed is my radius times my angular speed, 18 feet per minute.